दोनों हो गया, सैलरी काटने वाला।
कितना इम्पोर्टेंट है, क्यों नहीं ईंट का बना दिया गया? ईंट का बना देते हैं।
अरे यार, इससे तो बहस करना ही बेकार है।
Good afternoon, everyone. Now, our next guest speaker is Mr. Ashish Kanochia, sir. He is technical consultant at iCreate and is known for conversion of ideas from lab scale to commercial scale. He brings more than 20 years of experience in multiple dimensions of technologies. His area of expertise varies from artificial intelligence, Internet of Things, brain-computer interface, etc. Currently, he is monitoring and providing technological guidance to a number of startups in field of e-commerce and IoT. His experience to work with engineers, academicians, patent attorneys, and being inventor by himself make him sync well with new emerging technologies. Now, I would like to invite Ashish Kanochia, sir, to share his views on topic the recent innovation in assistive technology.
Hello. Am I audible, ma'am?
Yes, sir, you are audible.
Yeah. Thank you. Good afternoon, everyone. So, ma'am, is it possible that I can share my presentation over here?
Yes, sir, you can share your presentation.
Yeah, I guess it is saying ki it is disabled, host disabled participant screen sharing.
Yes, sir. Our team is working with this.
Sure.
Sir, is it now visible?
Just a second, I'll check.
Okay, sir.
Yes.
Okay, sir, you can continue now.
Yeah. Good afternoon. Yeah. So essentially, I'll begin by explaining what we do at our facility or our institution. So we basically belong to one organization that works on developing technologies and products for startups. And largely, these products are implemented in variety of sectors and domains. So, yeah. So So largely these products and innovations come from various sectors and domains. So many of our startups have been working in the field of education, edtech, as well as the field of assistive and disability-based devices. So whatever we have seen during last journey of our innovation and innovative and technical startups, so what we have seen till now is that there are so many misconceptions and myths around these things. So we'll begin by explaining what are these myths. So in assistive technology, whatever we have seen is that people believe that assistive devices are so yeah. So there are so many myths around assistive technology, and generally people believe that these are only meant for people who have some sort of impairment or disability. But generally it is not as such. Lots of people who are not part of the disability group need some sort of assistance somehow in using technologies or adapting with technologies or interacting with their devices or equipments. So as you must have seen in our mobile phone, the Android devices that we have, there is a separate area for assistive settings. So if a person who is not able to see the screen properly, they have that option that they can enhance the size of fonts, the size of icons, or maybe some sort of audio issues with them, so they can use the vibrating devices element on their phones. So assistive technologies are everywhere and they are required by lots of people because they have some sort of ailment or impairment that is chronic or you can say temporary. So the myth around assistive technologies is it is only meant for some people who are somewhere disabled or impaired, but it is in our perception needed for everyone in some case or another. So here the definition is the first myth around assistive is it is used only by the students with special needs. But if we can discuss a live example over here, so you must have seen that the old age people in our homes generally go to read Ramcharitmanas or Bhagavad Gita. And when you go to your bookstores, the Gita Gorakhpur bookstore, so they have a large book with huge fonts, and then they have small books with smaller fonts. So those books are assistive books for elderly who don't have that good
हाँ
eyes.
और फिर ये जब वहाँ पे जाकर सामने दवा देगा कोई मतलब ही नहीं है जब वहाँ पे लिखा है फालतू मतलब तुम खुद खराब कर हाँ बहस कर लेगा क्यों क्योंकि
Yeah. So generally, students who belong to all the categories, they have some sort of requirement of assistive support, and this can enhance their quality of learning from any grade. It could be preschool, it could be higher education, it could be anything. Now, the second thing is the cost of assistive things or assistive technology is so high. But normally, when we see that there is a huge spectrum of devices or technologies available, where it is a no-cost solution, like increasing a font in a textbook is a low-cost solution, and it can help a person in a huge way so that they can understand whatever is being like taught to them. So sometimes it is very low cost, it is not expensive, but in certain cases we have deep tech innovations in this particular area. So there are things related to augmented reality, neural networks and AI, generative AI, which are also a part of assistive innovation spectrum. So there are low cost resources, low cost devices, low cost materials and methods to assist people in enhancing their learning. And then there is a possibility of using very much deep tech and high end methodologies. So the concept is that when we talk about the third myth, it is about high end technology. So these high-end technologies are generally developed around the basic methodologies that we have. So in earlier days, when Microsoft developed the keyboard for a computer, they found out that a flat keyboard with a continuous row of keys was not natural for everybody. So they developed the adaptive keyboard, which was not created in a way that the keys were in a flat manner. So it was a keyboard where the keys were positioned in a way so that it helps a person for long-term use. So that keyboard was broken apart in two parts, and a person who wanted to position it as per the requirement of their positioning and posture, they were able to use it. So that keyboard was called Microsoft Naturals keyboard. So basic engineering technology is required for such kind of development. So I'll go ahead with the next slide here. So what is assistive technology? So generally assistive technology is termed under any device, software or equipment that can help. So that can help people work around their challenges. So it makes their lives easier. So certain examples are text-to-speech generators, word prediction, and your dictation softwares. So there are low-cost tools, as I mentioned earlier, like pencil grips, organizers, lots of things. Then any device, software, equipment that can help people. Yeah, it is repeated. So assistive technology are everywhere these days. So what are the specific tech tools that can help people learn them differently? So I'll start by discussing how they are designed or developed. So what are the impairments? where assistance is required. So generally, these impairments are visual, hearing, communication, learning, and motor. So the challenge is what kind of educational tools can be used here. So in case of visual impairment, any interactive screen projector, regular projectors, touch screen tablets, braille devices. So these are innovative devices. So one of our startups is working on these devices. These are pressure-based elements, and any kind of braille character appears onto their like device, and you can touch and feel the character appearing on that device. So if a person wants to read what is being shown on the screen, that particular device that he can touch presents these characters in braille script. So these are some innovative developments being done in the field of visual impairment using tactile braille devices, touch devices. Then there are smartphone magnification software or even assistive element inside your Android. So these are things which can enhance the size of font or any particular icon or any particular area on your screen. Then there are screen readers which can read whatever the content is available on the screen, and they can dictate it or narrate it to you as per your requirement. So there are so many methods which are available for helping a person with the impairment coming from the visual effect into his life. So normally these materials are there is excess written and oral material. So written material ke liye they have braille transcription software which can read braille and speak it up to you. So like we have optical character recognition or some sort of dictation softwares which can read English and tell you what is written on the screen. Lots of companies and startups are working on technology where they can read braille and then they can narrate it to you what is written on the screen or on a particular book, so on the particular surface. So then there is screen magnifier, optical character recognition methods, reading machines, scanners, and so many things are there. So the challenge when you talk about visual is largely focused on braille for reading, color differentiation for people who are color blind somehow, people who have limited vision, for them enhancements and amplifications and magnifications. So that kind of enhancements or technologies can be developed for the people coming from the impairment of visual or a visual handicap. So now, a person who is going through visual impairment needs some sort of method to communicate with others also. So largely there is a need or requirement of a device that can communicate in itself. So a person who can type on braille can send any kind of data to somebody else, and who can read that braille data using that device, which can provide the technical or haptic feedback based on the content written in simple English. So these devices are being developed by a variety of startups or organizations who are into this kind of space. So then there is hearing-based impairments. So largely hearing impairments are focused or available in the market as hearing aids. So these are largely some amplifiers or some sort of microphones and set of devices which can hear any auditory signal coming into the range of human hearing and amplify it and provide it to your eardrum. Or else there are cochlear implants which are connected directly to the inner ear of a human being through the surface of the brain. These are invasive, but these support people who have some sort of disability related to their hearing. So in case of hearing, we have hearing aids as well as cochlear implants, and then there are sign language based things. So people who can't hear, they can see, like that. The people who are totally disabled from the hearing part can see on the screen what is happening. So one of the startups that we supported has developed a technology where he has translated huge number of Gujarati and Hindi books into sign language material. So whenever you want to read a book, you just open that book and that person explains the concept of that book in form of visual representation as a sign language. So that means if you want to understand what is written in that book, so instead of a lecture, you can read it from a small digital avatar that is shown on the side of the book, and that avatar shows you in sign language what is the meaning of the writing that is on that book. So he has converted lots of primary and secondary education books and materials into a small gamified avatar that uses sign language and shows the expressions and meaning of that content. So it is like teaching or giving a lecture through sign language, but it is not done by humans. It is done by small avatars who can read normal text in Gujarati, Hindi, and English, and then they convert it into sign language in the real time. So sign language based learning materials and training tools are being developed, which can enhance the learning experience for any person who is disabled with hearing and speech. Then there are text to speech based softwares. So these are widely available. The facilities, the technology is integrated into our mobile phones and laptops everywhere. So this gives a person the capacity to speak up, a person who is deaf and dumb. So it provides the facility to speak up. So whatever is written in form of a text or even in form of gestures, it can translate to speech. So one of the startups created a small glove. If you just wear that glove onto your hand, then you can use some of your gestures, hand gestures, and those gestures are directly converted into speech through a small speaker. So a person who is not able to speak can use that kind of glove to generate a speech. So that is one of our startups who developed this technology in 2017.
हमने जाके जाके तो वहाँ पे जाके पहले तो आइडिया आना चाहिए आइडिया वो अच्छा है वो नहीं बना पाते अभी तो
So now, these things use a computer for communication. Largely, when there is an impairment in communicating any thought or any idea, you need to have some sort of device that can communicate whatever you are thinking. So I can give you the example of Stephen Hawking, the scientist. So that person was majorly disabled, and lots of his motor functions and speech and lots of his capabilities were not functional. So he had so many thoughts around the universe, space, black holes, and theories, and he wanted to communicate to us in a larger way. And he did that through a specially designed computer interface, which was able to pick up his gestures and some possible movement that he was able to do. So he was able to move a small cursor around, and from that he created those theories and ideas which he wanted and thoughts which he wanted to share with us. So we have read or gone through so many of his books, but the person was totally disabled and he was not able to communicate to normal human beings. So he used the computer, a specially designed computer, as a medium of communication, or even as a medium of communication to the people who were around him. And that technology was used to deliver his ideas to us in form of a book or in some form of lectures. So for communication, you need some sort of intelligent device like a computer or a mobile phone or a tablet, which is especially customized and designed for a person who is not able to properly communicate. So the challenge to these kind of people is generally, or to solve these challenges, they use text-to-speech softwares and screen readers to read the content to them. So there are further things available, that is people with learning impairment, people who are not able to learn things in a good way. They need special and custom designed methodologies to teach them how and what kind of content they or understand and analyze what kind of content they can study and what is their rate of learning or rate of grasping, and how and what mechanism should be followed to provide them these things. So especially designed fonts, especially designed contrast and such things, especially configured contrast and settings, provide people with capability or enhanced capability of learning. So again, For learning disability, there is a custom set of requirements and tailor-made specifications which enable them to grasp any concept or knowledge directly. Then again, there is a problem with the motor capabilities of a person. A person who is not able to use their hands or their fingers or any kind of gestures or anything. So for them, there are special kind of interaction devices, or you can say haptic devices available. As I told you, especially designed gloves which can enable a person to speak, especially designed joysticks or mouse or such things. The recent development is in this direction is going on in US with a company called Neuralink. This company was founded by Elon Musk. So in Neuralink, they have created a small device which connects to a brain of a human being, a disabled human being. This device is invasive. This invasive devices, there are two types of brain computer interface devices. Generally, BCI devices are available as non-invasive and invasive. So non-invasive devices are used as a headgear. You just wear them onto your head and then they can read signals from your brain. But those devices are not very accurate and not very much focused. But when you talk about an invasive device, these invasive devices are normally uh, focused and precise, but they are invasive onto your brain through a hole drilled into the skull. So this Neuralink device was implemented onto a patient who was totally paralytic. And that device enabled that person to use a mouse cursor as a normal human being. And during last 1 year or so, that person was able to learn to use that device, then started playing video games through that device, started using a computer through that device. And I think last week or a couple of weeks back, they have done a second operation on that person, and they are adding one more device onto his brain. Now he will be able to use second device as a keyboard also. So a person who is totally paralytic, can't use his motor actions or fingers or even hand gestures, can operate a complete computer through his thoughts. So Neuralink is the company which has developed such kind of assistive device. It is invasive and especially designed for such kind of cases, but it is a device which enables human beings, uh, people who have some impairment or disability, to function in a better way. So there are impairments and there are different types of possibilities for such impairments to solve them and to provide them with a better learning or functional experiences. So visual, hearing, communication, learning, and motor. So these general impairments, the technologies around them, as we have discussed, need some sort of intelligent device like a computer or a mobile phone or a tablet, some sort of text-to-speech functionality, some sort of font screen magnification, and such kind of technology, or maybe BCI type haptic devices, interface devices, or smart glove, yeah, braille reader type haptic devices. So these kind of technologies are being developed by so many companies as well as so many innovators, and these are providing support and kind of help in this particular dimension. So recently there was a report from World Bank about including the impaired mass of our population for learning. That was for inclusive learning. So they have prepared a report. World Bank has prepared a report in January 22, I believe, and that report is largely focused on inclusiveness of education. So they have divided it into the system of 5 P's. So it is about people, what kind of people, who are the users, what level of requirements and impairments, and how it is going to be largely deployed into the society. So who is implementing it? So who are going to use it and who are going to implement it? So that is the definition of people, the people involved in inclusion of disabled or such kind of people. Then there is provision. How this intervention, whatever development being is done, is it being supported through some funds, some CSR, some innovative support, some sort of like NGO type funds, or what is being done to provide the support, the financial support. So place, the demographic, or you can say the geographic place where this thing is going to be used, the larger landscape of applying this technology as a pilot, as a test, and then later on as a mass scale implementation. So what is the government stance? How government is supporting this through policies, through trials, through speeding up the clinical methods, or to speed up the policy in terms of deploying it. Then there is pedagogy, where it is what kind of required pedagogy or methodology which is going to be implemented into making this as an adoption huge scale, and what exactly is the product. So what product is being developed, what kind of service, and how it is going to be delivered. So this is a methodology, a 6P methodology of implementing these innovations into different levels of society. People who are coming from primary education, from secondary, from advanced professional education, skill enhancement. So where and how this thing is going to happen. So it is a method to study the impact of the development or the innovation into the masses. Now, so in this report and some other, you can say, methods of inclusion, there is a need for having a universal definition of learning. So it is called generally universal design for learning. So when we talk about any product, these products are designed for human use, and they are largely designed for humans who are common in nature, the homogeneous population. So when we see the mouse or a keyboard or even a bike, generally these things are designed for right-handed people, and sometimes the left-handed population feels left out. These things are not properly designed for us. So till now, most of the design for our products and for our architectures, for our buildings, for all kind of things, these things are generally designed for homogeneous population who use their right hand. The right hand is dominant, so who use their dominant hand, and the products are designed in that manner only. A particular height, a particular way of movement, a particular preference of using a hand. So because the products are designed in that way, so many people are not included, or so many people are not capable to adapt to these products. So there is a need for designing for inclusion. So these design for inclusion takes universal design for learning methodology in application. So when we talk about design, every product that is designed needs to have some sort of function. When you talk about using a mobile phone, it has a function, it has a functionality. So normally this functionality is focused largely towards communication. So we use a mobile phone for a functionality of communicating with others. That is the primary functionality of a mobile phone. But then there is a form involved. That means the form factor of that mobile phone. So if it is too small, it would be problematic for us. If it is designed in size of a small watch, it would be a problem. If it's a mobile phone is designed in size of a laptop, then again it is a problem. So functionality is one part of any design, but form is another very important part of the design. So form takes into consideration the aesthetics, the ergonomics, the usability of that device. Functionality takes into consideration the technology part of that device, the uses part of that device. Then there is a fit. That is where the size, weight, and such things fall into place. So any intelligent design comes from form, function, and fit. So if we talk about understanding this further, so when you see a car, there are so many forms of a car. Functionality is same. Any car can take you from point A to point B. But forms are different, fit are different. So there are different fit cars, like a small car, then there is a sedan, then there are SUVs, then there are different form factors and sizes. So any product when designed needs these three things: form, function, and fit. So universal design for learning takes these things into consideration. So UDL considers that everybody universally should get included into any product, any application, any technology by considering everybody as a part of the whole, and form should be in a way that is consistent with everyone. Functionality is in a similar manner, and fit is also in a similar manner. So universal design for learning. So what exactly it is? So generally people believe that UDL is just for students receiving special education and services, but it is variability in all learners, not just disability. So anybody can get benefited from something that is universally designed. So it is not just for special need students or special need people, but it is for everybody, as I mentioned earlier. So UDL is the same thing as differentiated instruction. So UDL is distinctly different education framework that proactively removes barriers instead of uh, reactively addressing. So it proactively adds value to the methods of teaching. It proactively, constructively delivers better content or gives a better experience. So UDL is generally focused onto that part. So then a myth is that UDL is just good teaching or good transfer of knowledge maybe. So UDL is again an educational framework based on decades of neural understanding, that's neuroscience, that teachers strategically implement to improve the students' outcome, to enhance the amount of knowledge shared and to enhance the level of grasping. So as we have seen, any content delivered in a monotonous manner is not interactive enough to give engagement to the student. But in this case, if the things are interactive, explained in a better manner, and a person gets engaged with them, so these things give a better outcome in terms of learning. So universally designed content for education, universally designed methodologies for teaching, universally designed equipments and devices and things for transferring knowledge, so that the overall experience of the learner becomes better, overall grasping and understanding capability gets enhanced. So that kind of information, that kind of development is done under universal design for learning. So UDL and personalized learning are the same thing. So it is again different. The UDL can be used as a framework for personalized or precise learning methodology, but not all personalized learning experiences are designed with UDL. So personalized learning is there, designed for a particular class, a particular group of students, designed for a particular uh, like impairment, but all are not designed with UDL. It should be, but they are not. So UDL is all fun and games due to its interactivity and due to its engaging nature. Generally, it is believed that it is all very gamified and fun and games kind of a thing, but it is not like that. So UDL-based frameworks design education in a way that these lessons can be fun in a way they are designed like that, but oftentimes they are not. The key is that they are engaging and worthwhile. So again, it is like watching a good documentary. So when you read a good book, you get say half of the content, but when you watch a good documentary on the same content or similar content, you grasp a little bit more because it is designed in an interactive and explanatory fashion, maybe sometimes better than a textbook. So that's why YouTube videos sometimes are a good way for grasping because they explain the methodologies in a better way, and it is tough to grasp from simple paragraph or writing. So UDL is not totally fun and games, but it helps. So UDL is against explicit instruction. So it is direct instruction still has a place in UDL classroom. So direct explicit explicit instructions have a place, but it tends to be a smaller part of the thing, and it is supplemented with other activities, supports, and challenges. It is bit about kind of gamification of things. So it is like quiz or such kind of methods, ranking, and these methods are incorporated in UDL things. So universality for inclusion, that is the purpose of this thing. So this helps in various ways of creating content. It could be online content, it could be books, textbooks, it could be presentations, and it could be the user experience for a person who is impaired somehow. And this universal design methods, which take into consideration the form, the function, and the fit part of things. So these are used. So when we talk about the basics of these things, so everything fits into some set. So there are three different breakdown into things. How these assistive technologies can be handed over to the masses. So there are no tech type things where there is like kind of no cost involvement or lesser cost involvement. Then there is low tech things. So things which can be done onto like social media and YouTube and such kind of frameworks. Then there are high-tech things such as virtual reality-based methods and platforms, augmented reality-based things, hardware devices which can enhance the level of interaction, haptic devices which can involve with you. So it is generally classified in no-tech, low-tech, and high-tech things. So when we talk about assistive technology basics, so considerations when choosing the accessibility and useful teaching and learning materials for learners with disabilities. So access is a very important thing, the connectivity part of things, because largely communication is the key in delivering content or maybe even taking the feedback of the learner. So access to devices and connectivity is of primary importance. The relevance of material and content. Material and content constructed in such a way that it crosses over the impairment. So a person who is impaired visually gets the content through the auditory senses which are functioning. Or a person who is not capable of hearing can read content from the screen maybe. So access to devices and connectivity, relevance of material and content, alignment with cognitive needs. Here the speed of learning comes into place. So if speed of learning is not very high, they are not able to grasp the concepts, they are not able to understand the uh, like thoughts and things. So how this can be better understood? So that is alignment with the cognitive needs. Then age appropriateness, designing the content in a way so that it can yeah, or it should be designed in a way that it works differently for the people who are of a certain age. So again, like primary education, secondary, and higher education. So appropriate according to their age level. Then if it is a hardware device or it is a haptic device or any kind of interaction, human machine interface HMI device, so the physical ability to hold or manipulate should be there. So if you design a device that can't be handled, as I mentioned, a mobile phone which is the size and fit of a laptop is not going to work. So it should be light and handy, something that can go into a pocket. So that is the right form and fit of a mobile phone. Functionality remains the same, but the size and fit and the form is very important. So physical ability to hold and manipulate the device, be it any assisted device. Then sensitivity to screen or white light. People who are sensitive to lights or flashing screens or such things, that should be in consideration, because most of these devices are either visual or auditory, text to speech or screens. Then availability of translators or interpreters. As I mentioned earlier, in that sign language thing, so the books written in Gujarati get converted into sign language through a digital avatar using the capability of AI. So any kind of actual translator or interpreter or any kind of digital translator or interpreter. That if that is there, who can explain the concepts in a better way, it helps a lot. So the point is, when we talk about involving artificial intelligence and generative AI in assistive technology or impairment and disability landscape, these are kind of innovations. A digital agent or AI agent that can do these kind of things. These are very important and these are very good directions of innovation right now. So finally, level of digital and ICT skills of learner or caregiver. So if a person is not comfortable with using a mobile phone or any specialized or specially developed device, then there would be a problem. So even if the content is designed in a proper way, a person who is not able to use the device cannot grasp the content or cannot communicate. So the level of digital skills or ICT skills required for the learner or for the caregiver, that is very important to understand. And then access to the parental or the guardian support or the ecosystem support for such things, or even the government support to provide that kind of functionality to the impaired person or a disabled person. So lastly, assistive technology as a product or as a solution gets divided based on these requirements: the access to connectivity, the relevance of material and content, alignment with cognitive needs, and all these things. It falls into three different level of complexities, that is no tech, low tech, and high tech. So no tech is again reading materials, work packets, or contents, study materials designed in a special way, considering the challenges, and educational toy or interactive games and challenges. So that it is a very low cost thing. Any educational toy which can enhance the level of grasping helps a lot for these kind of learners. So this is a very low cost or almost no tech and no cost thing. But when we talk about lower tech or higher tech, so suddenly different kind of innovation and things start building around it. So low tech is something like, as we have video conferences through WhatsApp, FaceTime, Zoom, Skype, Teams, lots of platforms are available. So this is now a widespread knowledge. Everybody uses these kind of technologies for learning, especially after the COVID era. So these kind of social media and video conference based learning is already there, and people are well trained in that. Multimedia resources like presentations and visual aids, especially designed. So these are very low cost and low tech thing. Then broadcast media, the content designed in a way so that it helps people. As we used to see the Doordarshan news for disabled. So that kind of content from coming from broadcast media, radio and TV and so on. So this is low cost methods to provide learning to the masses with disability. High tech, there is live real-time classrooms where a person physically is available to broadly explain the idea or the content of the class or a session. Then virtual learning platforms where there are learning management systems, LMSs involved. These tools, these technologies sometimes are helpful to understand the kind of feedback that we are getting from the learner. So if we have a on-screen platform where a person is interacting with the content, so we can get his response time, his speed to answer, his way of choosing a particular answer. So we can get a lots of data to understand his behavior and then customize the content customized in real time as per the capability of the learner. So if a learner who has a lower speed of grasping, a lower capability of grasping, so if that person is interacting with a cloud-based virtual learning platform, the platform will automatically estimate the learning speed and the reflex time of the learner and automatically customize the complexity of questions being asked. So it can fine tune it to a slower pace or even easy questions and answers, or even it can take the answers to a tougher level. So a system, a virtual learning platform that can adjust according to the learner by understanding the feedback. So that is a high tech thing, where a feedback in terms of mouse movement, speed of response, quality of answers is taken in, and then particular algorithm goes through that data and creates some sort of metrics where it generates questions relevant to the learner. So everybody who is learning from that platform suddenly gets fine-tuned according to their personal capabilities. So it is not one size fit all then, it automatically fits to the learner's capability. Then there are so many apps available on the Play Store for providing such kind of interaction, and then there are software games. But generally, haptic hardware devices, artificial intelligence, augmented reality, virtual reality, these kind of advanced technologies are also there. So we can talk about those further, and some case studies and examples of the startups which are working in this field are also there. So no cost is there. Yeah, so I already mentioned all these Braille contents and such things. So they have Braille books which can be generated. So there are some companies or startups or you know, who wants to read a book or some content can get a page printed out in Braille and can read it directly. So then there are audiobooks and ebooks. So many platforms are available for audiobooks. Then there are software screen readers, so which can read the content on the screen, so can help a visually impaired person. So these are some advancements. So smart glasses. So one of our startups right now has been through pilots of these glasses. He has been developing these since last 3 years or so. So these are smart glasses which have a small camera integrated inside them. The company is called Sonont Technologies, I believe. Sunbot Technologies, I believe. So this person has developed these glasses. These glasses have an integrated small camera. That glass connects with your mobile phone through a small wire, and that wire goes into the USB charging port of your mobile phone. Then that glass starts streaming the visual information that it can gather from the environment, and there is a small software on the mobile phone which goes through the information and processes the information and comes up with alerts, or you can say notifications around the surrounding environment. So for example, if a person who has a limited visibility or who is visually impaired can use these kind of glasses, and whenever he is walking around, these glasses will notify him that there is a car in front of him, or there is a table in front of him, or maybe there is a pet coming around or something like that. So these glasses do the job of visually analyzing the environment of the person who is wearing the glass, and then gives them a real time feedback onto the environment. If that person is reading a book or a newspaper, these glasses automatically start reading the content written on a normal newspaper. So the person who is visually impaired is just required to wear the glass and connect it to his mobile phone, and automatically he will start getting all the visual feedback. So there is no need for any braille newspaper. He can read a regular newspaper or listen to a regular newspaper directly through these smart glasses. So this is one invention that is done by one of our startups. So they have developed this thing. These things are capable to recognize faces, items, products, everything. So, and these guys have developed it at a very low cost for fit for the Indian consumers. Right now, they are testing these devices with some blind school here in Ahmedabad. So these people are actively deploying these devices in bulk. Then, as I mentioned, there are smart gloves. One of our startups has done these. So these translate sign language. The sign languages are American Sign Language ASL and BSL, British Sign Language, as well as Indian Sign Language. So these gloves are capable of understanding the hand gestures, and then they take these hand gestures and convert them into words and sentences, and then they play back these words and sentences as a speech. So again, these get connected with your regular mobile phone through a USB port. Whatever gesture you make through your hands movement, automatically it is able to grasp them, and then through the loudspeaker of your mobile phone, it can speak whatever you want to. So these are smart gloves. These again are very low cost solutions. So the smart glasses company started working in this field around 3 years back. The smart gloves company has been working on this for the last 4 or 5 years. Both of these companies have developed and patented their products. They have done their pilots. Lots of products are already in circulation. People are using them, and lots of companies are interested in spending their CSR money to make these devices available for the masses. So these kind of technological advancements are required in the industry to enhance a person's learning capability or communication capability through innovation in deep tech. Then there are AI-enabled hearing aids. So these hearing aids are the smarter version of hearing aids. So these use AI for analysis of things. So sometimes, so these are very expensive right now, and these are largely under development because AI again is a new phenomena, and especially in this particular sector. But these hearing aids have a capability to use AI to analyze the environment sound and then make or generate some sort of meaning out of it. So these are not those standard hearing aids which just enhance the level of audio available, but these can also process the audio incoming and give you the notification and alerts through that sound. So as it is mentioned, these hearing aids such as Oticon Open leverage artificial intelligence to analyze and adapt to a different sound environment and enhancing the speech understanding and reducing the background noise. So as you must have seen, there are lots of earphones available in the market which have a capability of noise cancellation. So those earphones can cancel out the environment noise and you can listen to your music in a very good manner. Similarly, these AI hearing aids are capable of analyzing the environmental sound, and they can reduce the noise from that sound so that you can clearly listen to any message or discussion happening. So these have a capability to automatically adjust themselves, but these are under development and they are not gone into the mass market in a big way in India. So these are a bit expensive. So these devices have deep neural networks inside, like we have our chat gpt. So chat gpt is built on deep neural networks. So similarly, these devices have smaller neural networks, but they are deep DNNs. So to continuously learn from the input, and then it can process the sound according to the user's hearing capability. Similarly, there are speech recognition and TTS. It is called text to speech. So these text to speech type things can convert any written text into speech, understanding the phonetics and the sentiment of a voice and the context of the written sentence. So these text-to-speech devices can generate any sentence into a proper verbal speech. So these days, lots of YouTube videos and lots of speech or audiobooks or content is being generated through such kind of text-to-speech methods. So they are not using humans now, they are using AI-enabled text-to-speech converters. They can speak any book or a content or a literature in a way so that it seems almost human. So these kind of deep tech and AI-enabled text-to-speech methods are already there. So they can take any written word and convert them into speech. Similarly, speech recognition. So there are two technologies here. One is speech recognition, another is voice recognition. So if you are saying a sentence, it can recognize what you are saying, like your Alexa does. If somebody else is saying the same sentence, it can recognize the content of the sentence. So that is called speech recognition. But when you talk about voice recognition, it is not totally about understanding speech. It is about understanding voice. So voice recognition is capable to understand who is speaking. It is not what is being spoken. It is about who is speaking. So when you talk about voice recognition methods, they are different from speech recognition methods. Voice recognition is used to identify the speaker. Speech recognition is used to identify the content spoken. So both these technologies are developed. They are there in our Alexa, they are in there our Siri, they are in Google Assistant, and so many other places. And they are very well accepted in your disability and impairment sector or domain. These speech recognition methods till now were developed based on a homogeneous population. So they expected the incoming voice or speech to be clear and to be like there should be no corruption or contamination in that audio. But when we talk about people who have a disability in speech, maybe their speech is not that clear, maybe it is a bit muffled, or maybe it comes with a little bit of stuttering or something like that. So when we talk about speech recognition in a traditional manner, those systems were not able to grasp such speeches. But when you talk about using a AI enabled or generative AI enabled speech recognition method, so these methods are capable to adapt to the speaker. So if a speaker who has some sort of disability in speech, not clear with whatever he is speaking or such kind of problems, these adaptive speech recognition methods can take over and understand what is being said regardless of the corruption of audio or lack of clarity of that audio which is being spoken. So using artificial intelligence based methods in these things can enhance the level of understanding of speech as well as generation of text to speech in multilingual way. Like it could be Hindi, it could be Gujarati, it could be Marathi, it could be any language which can be scripted and phonetically reproduced. So here it is mentioned the technological aspect. This involves deep learning models trained on large data set of spoken language to accurately convert speech to text with higher accuracy. So next is smart pens. So these are already there. We have seen them, these kind of pens with Apple Pencil and such things. So normally the thing is so cheap these days, so you can buy a clone of Apple Pencil for around 1,000 or 1,200 rupees. Apple Pencil is expensive, but a clone is available at 1,200 or 1,500 rupees on Amazon. So these devices, like smart pens, these allow students to take handwritten notes, which are simultaneously digitized and can be synced with audio recording. So this helps students who have disability, who have difficulty with traditional note taking. Now the challenge is somebody with dyslexia is not clear with whatever he is writing, and there can be glitches or errors or mistakes in his writing. But if he uses a smart medium like a tablet and a smart pen, whatever he is writing is automatically being handed over digitally to AI, and AI can then make sense out of it and continuously keep on autocorrecting it, continuously learning from the writing methodology of the person and automatically adapting in a way so that even if he does some error or some mistakes in the content being written, automatically this AI jumps in and recreates it or re-engineers it in a way so that it is properly stored, as well as it can play an audio feedback of things being written so that a person understands what he is writing down and whatever is being written in the stored in the tablet or the note-taking device. So smart pens and smart devices is like that. Then there are eye tracking devices. One such device was deployed with Stephen Hopkins, where it was able to identify the movement of his eyes, and from that movement, it picked up the movement of the cursor on the screen so that he was able to type onto the screen. So because Stephen Hawking was totally disabled, eye tracking devices were used to track the gestures or the movement of his eyes, and then blink of eye was used as a click, and on screen keyboard he was able to use an on screen keyboard, and from that he used to type down every letter through the motion of his eyes. So the example is devices like Tobii Dynavox uses eye tracking technology to enable students with severe physical disabilities to communicate and interact with computers using eye movements. This technology provides a vital communication channel and access to educational content. So this is a technology which has been there and being developed since a long time. This technology was used by Stephen Hawking for writing down lectures and books and everything. Now, due to the advent of such strong microprocessors, cameras, and tracking algorithms, and artificial intelligence based methods, these things have like kind of refined in a way so that they can give the learner or the user a very good experience on controlling the mouse cursor or the content being written. So people with severe disability can use this kind of technology. So low tech I have mentioned earlier, but here are certain examples. So these low tech things are generally using GPS for locationing surroundings and smart glasses for understanding the surrounding of a person, or even things like ultrasonic detectors. So there are some startups. So one of those startup is working with LMCO. So LMCO Kanpur. So that startup has developed a stick, a blind stick that can detect any kind of obstruction in front of him using ultrasonic detectors as well as some sort of optical detectors, and can give some sort of vibratory alarms to a person who is like kind of impaired with vision. So they can provide real-time assistance through applications, like mobile applications, GPS-based, GIS-based technologies, micro-locationing inside a campus because GPS is not accurate in smaller spaces. So for larger, it is very good, but in smaller spaces or places which are inside a building, GPS gets inaccurate. So for that, we need micro-locationing devices which can guide a person through his surrounding and complex environment so that they don't get lost in the area. So that kind of navigation apps and devices. So educational softwares and tools. Back again, there are so many audiobooks and learning mediums and such kind of tools and softwares are available. Then text to speech, it is already there. So many developments are being done in this particular sector, and we have so many startups with us doing all these. Then smart tablets. So we have some startups who are especially designing some sturdy and rugged tablets for everyday use in such kind of special environments. So generally regular smartphones or tablets or these devices cannot be used in the rugged use cases where there is a possibility of spilling a liquid onto the device, or maybe like a device that can fall on a regular basis. So that would be a huge problem. So if a person who is impaired, sometimes their physical or motor actions are not that good, so that they can maintain these devices in their hand, and maybe they cannot hold these devices for a longer duration, or maybe they tend to spill things onto the devices. So rugged devices which can survive in a hazardous environment are being developed, especially designed tablets and UI UX devices, HMIs, for learning and such kind of cases. So those are being developed by the startup. So then there are interactive learning tools based on augmented and virtual reality. So again, as I mentioned earlier, these assistive technologies are not just limited to the people with disabilities. These are for general public and masses also. So 2 or 3 of our startups are working on augmented reality technologies, and they have a vertical of providing technologies to the disabled also. But right now, their mass market, the market that they are targeting, is for normal human beings who are fit. But again, these augmented assistive devices are helping them a lot in their day-to-day exercises. So what these devices are doing? So there is one company who has developed a device which helps a person in an environment. Let us say it is an industry. So if a person is moving around in an industry, in a factory, where there are hazardous things happening around him, say somewhere there are higher voltages, somewhere there are higher temperatures, or some rotating machines which are working at a higher speed and such things, some hazardous or critical or like dangerous environment is there. So if the person is wearing a smart glass with AR, so automatically those locations gets highlighted and notified to the person, so that he remains to a distance of those areas. And if he gets too close, these devices start alerting him by vibration, by audio signals, by flashing lights, so that a person remains safe in a complex industrial environment. So right now, these companies, these startups have developed devices for such use cases, but these are very useful for disability and impairment sector or domain. So where people who cannot see, or maybe you cannot hear too near to such kind of environments. So if they have these kind of devices with them, automatically they'll get the information, augmented information of their surrounding, and get some sort of alerts based on the surrounding of that person. So in high technology things, advanced things, we have this BCI happening. So it is again invasive and non-invasive, both methodologies. I mentioned invasive methodology from the company called Neuralink, which is actively working on to provide some sort of assistance to people who are severely paralyzed, or not people with abnormally functional or not functional motor capabilities. So these BCI things are invasive, go into the brain of a human being, pick up signals from the neuron interaction through the complex folds of a human brain, and then make meaning out of it and provide them with assistance in controlling their wheelchair, maybe controlling some sort of computer or controlling some sort of communication device. So this is already there. Very recent development, still going through level of trials. Right now, the human trials are being done. There is one person involved in those trials on whom these experiments are being done. Maybe very soon, these devices will be available off the shelf for inclusion of people who are at a severe stage of disability. So this is a very good development moving in the field of BCI. And generally, there are non-invasive methods which are based on electroencephalography, that is EEG. So these are EEG headsets. A person wears them as a hat or as a headband or as a cap, and then it is able to pick up signals and then make meaning out of those signals, generate meaning out of those signals, and helps a person in some way, whatever is necessary. So I can give you one example. So there is one company, it started around, say, in 2017. So I was consulting to that company, and they have filed around 9 patents around their technology, and that is a non-invasive BCI company. So that non-invasive BCI company has developed a small hardware, a small circuitry. It is basically one electrode that get placed onto your head. It picks up the signal from the forehead and then amplifies it, processes it, digitizes it, and then sends it to a computer. So that is the sensor that they have developed. Now, the functionality or the capability of that sensor is that sensor can pick up your level of focus or distraction from a particular task. So it can detect if you are focused onto something or if you are distracted from something. Just very basic understanding of how your brain is behaving right now. Are you focused onto a topic or are you not focused onto a topic? Now, they have developed it to create a small cap or a headband for students, like primary students, young age students, and they have developed a software, a complete set of software tools, a complete suite of software, where they have developed a technology so that, let us say there is a classroom of 60 students and everybody has to wear that band during their classroom sessions. This band can pick up how many students were interested in the class and how many were distracted in that class. And based on that, a data can be gathered that these many students are not interested in lectures around history, but they are very much interested around lectures in maths. And these many students are not good with chemistry, but they are good with learning history. They are focused in history classes, they are distracted in chemistry classes. So that to learn more about particular subjects or topics, you can decide their course of life, you can decide their preferences of learning, and you can push them into a direction where they are more comfortable and more focused instead of where they are less comfortable and distracted. So that company has developed this kind of solution for enhancing the classroom experience and providing more personal learning to the student. So brain computer interface is an emerging field. Things have been happening in this direction since 2012, I believe. And right now, it has taken up some pace. It is speeding up. And very soon, we will be able to see some sort of technical things, products coming out of it. So this is some high-tech development being done. This was Neuralink that I mentioned earlier. So it aims to create high-tech, ultra-high band BMI, brain machine interface, to connect humans and computers. So their larger objective is huge. Right now, they are at very early stage. They have developed just a device which can enable a person to control a mouse. But their long-term goals are kind of science fiction. Their plan is to develop a device which can connect to your brain, and if you want to develop a deploy a lecture session into your brain, so automatically you can just send it to your brain and it understands the lecture. So it is like copying the content from your laptop or from your mobile phone, or sending the content from your mobile phone directly to the brain, and vice versa, sending the content from your brain to the laptop. So in future, they want to create an interface between computer and humans where information can be downloaded or uploaded to a human being or from the human being as easy as we do right now onto pen drives and cloud. So this is their long-term goal, interfacing a human brain with a machine to enhance the learning capabilities of a person. So this is Neuralink. This is by Elon Musk. So that was about the enhancing the mental capabilities of a human being. Here it is about enhancing the physical capabilities of a human being. So exoskeletons is something which has been developed by the American defense as well as globally. So many countries are working on these things, uh, creating robots which look like human beings, like humanoids developed by Boston Dynamics and lots of other companies. So exoskeletons are very much like a robotic framework, but these are not independent robots. These are mounted onto a human being and then they become extension of that human being. For example, if there is a person who has a disability in his legs, so there could be it is like a prosthetic. So there could be a specially designed exoskeleton which can be mounted along with that human being, and it can enable them for movement, for interacting with the real world, grasping the knowledge and the skills around him. So that is for you developed for rehabilitation and mobility, enhancing the mobility and rehabilitation. So a person who is disabled to a certain extent. For example, here it is mentioned about the spinal cord injuries or maybe some physical disability. They have problem with the standing and walking and maybe running around. So these kind of exoskeletons can support them in that way, so that a human being with that kind of disability automatically reintegrates back to the real world and can start interacting and learning and grasping the things around him. So these are like robots, but they are mounted onto a human being. That's why they are called exoskeletons. So that means these are skeletons which are outside of a human body. These are variable exoskeletons. So these are also developed for the soldiers in battleground. So it makes them carry more load and weight on their bodies, because now a robot is going to handle that weight. So a human can carry a lot more wearing this kind of exoskeleton. So these are some things which are um, being developed in the field of mobility or physical disability. So there are innovative companies who already have come up with prosthetic joints and arms and palms and legs, which are controlled by the computer. So these exoskeletons are generally controlled by the signals coming from a human body. So sometimes these are the neural signals coming from the nervous system, nerve ends, and these technology, or sometimes they are EEG based, like I mentioned earlier, the BCI based exoskeletons. So there are technologies doing that. So then there are so many startups in India which are developing lots of things around accessibility and such kind of devices. So this is a company called Karosambhav. They have developed a solar powered hearing aid and sensory impairment scale. This is very much helpful. So this can keep on charging. So you don't need to you take that hearing aid out and put it to charging. It is automatically charging even when it is in use. So and that means it is not going to use your grid energy. It is working on solar energy. So it is kind of using renewable and it is sustainable. So they have developed a solar powered hearing aid. Then there is Bionic Yantra. So they are developing so many mobility solutions. As I mentioned earlier, the exoskeletons, which have sensors and actuators, and they are developing it as prosthetics. So there are assistive technology startups working on these kind of things. Then there are neurotags. So these kind of tags help in actual, you can say, show and tell type of learning methods. So these are tags can be attached to devices, objects, things, and they can give you audio description of that thing. So you must have seen such kind of tags around museums. So you just go there, and when you see those QR codes or tags, or even press a button, so you get audio description of it. Is like a virtual guide. You get audio description of that particular thing. So this company is developing those kind of QR tags and Bluetooth tags and such kind of text to speech software which can give you a descriptive information around anything. So this can help in learning in a larger fashion. So neurotags is one company. Then there is Cognable. These are providing learning plans and feedback for children with autism. So there is Cognable, there is Nima AI. These companies are helping people with, you can say, learning disability, autism, Down syndrome. And this company helps them for therapy sessions, for giving them the real-time feedback of the kind of learning they are able to achieve, or the kind of grasping the content that they can grasp. So this is totally AI based and can analyze patterns of their. So this kind of software check the attention pattern, how much you are reading from the screen, how much distracted you are. So what it does is it uses a camera, your laptop camera, and keeps a check of your focus, where you are focused, where your eyes are directed. So from that, it can pick up what kind of interaction you are doing with the computer. So this is cognable. So there are so many startups in this particular area. Yes. Hello.
Yes, sir.
Ah,
Thank you.
is it continue? Yeah, ma'am. So yes. So I thought you were like kind of saying something.
Yes, sir. Sir, are you done with your speech?
Yeah. So that was the last slide. So this was just about the close. Yeah.
So now I would like to say thank you, sir, for taking the time out of your busy schedule to be here and enlightening us on recent innovation in assistive technology. Thank you so much, sir.
Thank you, madam.